samples that I picked are from Kansas. I'm calling it cause and effect log analysis because really what we're talking about is certain things cause certain responses, and then we try to work off of those responses. There aren't very many cases in the logging business where we're actually making a measurement that we start talking about, well, that's the oil measurement or that's the water measurement. It's something that's related to the oil or the gas or the water measurement, right? So there's some cause and it causes an effect, and we're trying to take advantage of that response. Really, if you just kind of stand back, because I understand how this can get fairly confusing because we have so many different things that we're working with, but if you just stand back and look at the basic ideas that we're trying to get across, you really don't have to know that much to interpret your logs. You just have to know in general what the curves are trying to tell you to establish what a hydrocarbon zone might look like in a well. And a lot of it's done comparatively inside the same well bore. So you're comparing readings in one level of the well versus readings in another well, another part of that well. And what's the reason for that? Because typically, what kind of fluids are we talking about in the formations? Generally, we're talking about water, right? Associated waters in the rock. The odd case is when there's hydrocarbon in there. So we're just looking for that distribution or that change that we're picking up on the readings to establish where that might be. This is what I like to start with, because this interpretation model, it came from a guy in Canada. They have a lot of neat guys in Canada. They really work at this real hard. Very technology driven in Canada. And if you look at the model, it's basically a block, and he's establishing this like a piece of rock and then breaking it up into blocks itself. And you'll see on the left, it basically works from the left to the right. You have porosity, shale, and matrix rock inside of that piece of rock, and then we're trying to establish those things to the right. So we're going to try and do this just with electrical measurements inside the well bore. In the top, when you're trying to establish what the porosity is, first of all you have what we're going to call total porosity. Okay? That total porosity is made up from secondary and primary porosity in the rock. Well, we're going to actually try to make those measurements to establish what those two things are. So we're going to make a measurement, for instance, to tell you what the total porosity is and then break it into pieces. So you can start to, in your mind, establish what kind of a reservoir am I starting to work with. And then as you move to the right in that block, you'll see effective porosity. Well, that's what really determines what kind of fluids are going to move, right? How much fluid can move is the amount of effective porosity that's there. Then inside of that porosity, if you keep going to the right, you're going to have oil or gas, or you're going to have free water, right? This is where we get down, and we don't have a lot of different type fluids to work with. We're trying to establish the difference in those. Now, part of the problem is if you keep going to the right and you get to the end of this block, you're going to see residual and mobile, or the mobile portion of the fluids. Well, you're going to hear about residual and mobile from this point on, because those are the two parameters that really count. If it's residual, it's not going to move, right? So in terms of what kind of production I might see, whether it's oil, water, or gas, that residual function is pretty important. And it's not like it's that difficult of a number to get to. But you do this continuously, which one of the things that you've heard about all morning long is the ability to use computers in this business. It's simplified a lot of these things. We used to have to do this by hand. And you do this on a 2-foot interval throughout your log by hand, and you're going to find out it's a fairly complicated process. Well, it wasn't that long ago that that's the way we had to do this. Well, now that we're working with computers, we can look at these residual and mobile numbers and start to put some meaning to them that's a lot more definitive. And just so you can see what kind of porosities we're talking about, this would be examples on the left of well sorted versus poorly sorted on the right. and you can see the space being taken up by rock inside a formation. This would be a thin section, and you can see that porosity would be the pink portion. And this is the kind of thing that we're trying to interpret based on the log readings. What is that porosity number? What would be the percentage of porosity in a piece of rock that looked like that? And this would be kind of the beginning of the interpretation process. And then the boogaboo, which if you don't think about this every time you look at a log in Kansas, you're going to have a problem, is the eumoldic type porosity that we have in the carbonates. If you just look at the descriptions on the right for each of those pictures, you can see what's happening as far as what we're trying to do. The upper one's showing 28.3% porosity with a permeability of 220 millidarcies. Well, that's all well and good. Let's look at the second one. Porosity is 27.7, so almost the same number, but the effective permeability is now at 32.4. Well, that ought to start ringing some bells off in your head. There's something wrong. Why are they so different? Well, if you look at the picture, it kind of shows up. All those holes that are in the rock are starting to become disconnected, right? So the effective perm is going to be quite a bit less. The more they become disconnected, the lower the perm value is going to be. And at the bottom, I'm down to 19.4%, but that's still a pretty good porosity value, right? It's still pretty high. But now look at the perm. It's down to 1.6 millidarcies. Extremely low. So I've got the good porosity, but my permeability value is bouncing all over the page. That's why the term eumoldic is very, very critical in this state. And you'd better think about it when you're working in carbonates through every interval that you're looking at, because it can control what type fluid you're going to produce out of what you would think would be a similar type carbonate. Next, as you go down from the top to the bottom, okay, we talked about porosity. Now if we go down to the shale, this is something we have to have a handle on just as quickly as possible. We need to know what the porosity looks like, but now we want to, for instance, let's get rid of all the shale zones so I don't have to worry about those in my interpretation. And inside the shales, we've got clay, we've got silt, and we have total shale. So we're going to try and establish what especially the total shale value is. We may not worry too much about at this level what the clay and the silt volumes are, but we are concerned about what the total shale volume would be. And the fluids inside of that, we've got bound water, and then we've got this dry solid component. But the bound water we have trapped in the shale, we got locked on the surface and locked in molecules. So there's a lot of water involved with shales. But we have to throw this component out, if you will, because we're not going to call these reservoirs, right? So we want to make sure that we're trying to get this portion out of our analysis. Now it is kind of interesting because what's happened in the last several years all of a sudden? You hear this, you hear it talked about, you see it on TV. All of a sudden we have these things called what? Shale gas plays. Well, part of that, what we were doing in the past is great, except what's happening today. Now, if you don't have a big shale gas play, you're not in the business, right? If you're not in shale gas play in Pennsylvania, you're probably not doing very much, right? Or it's starting to become in every state. Everybody seems to be finding their own shale gas plays.